So like if we make array, and if we make array, then the problem with array is like maybe like number of patient if I make. So how many patient will come, I don't know. Like if I make 1,000, 2,000, 3,000, whatever I do, that is not sufficient for me. Even if I make 1 lakh, 2 lakh, that is also not sufficient. If at all I have to change it, what I have to do is like I have to change number and recompile. So this will not solve my problem. So we are having another method, and that another method is we can make a pointer and using dynamic memory allocation. So we can say the number of patient is equal to, you can say the malloc, and then we can say like whatever size of patient, and then number of patient thing. So but this number of patient is again like how we will know this. So what we can do is like either we can ask user. We can say user like, okay, how many patient you think will come. So even user also don't know how many will come, but whatever if he say consider, okay, as per my understanding, he will say, okay, this much will come.
Okay.
So when he say this much will come, then like you can, that much memory what you can allocate, but its problem is still same. Like if more come, then what?
Yes.
If more come, then what we have to do? We need more memory now. Consider user said 1,000, now we need more than 1,000. It means we need more memory. So if we need more memory, we are having a one brother of malloc, that is like realloc. So what realloc do? In realloc, we have to tell like old pointer, and then we have to say like how much we want, more, how much more we want.
Yes.
So then that much it will allocate. But the problem with realloc is it is going to copy the all data to the new location.
Yes, sir.
And this is like a serious affair. Reason being like so much data you are copying from here to there.
Yes, sir.
And as size is growing, then it will be problem. And one more serious issue with this is like consider in realloc, consider we have this much of memory, and consider like this much memory is already filled with our old data.
Yes, sir.
And now we want more memory. So what it do, it reserve more memory, like consider it reserve this much memory again. But at a time like this also busy and this also busy. Unless it copy it here, and then when it make it free.
Okay.
Once it copy, then it will free. That is fine. But until then, like this also occupied, this also occupied.
Okay.
So like it's a little like not recommended thing. So we are having a alternate method for all this thing that we are discussing for like quite some time. So we can make the struct, and whatever we want, patient, we can make patient, and then whatever information you want, name, age, gender, address, mother name, father name, whatever you want, medicine, address, whatever you want, you store it. I don't mind it. Whatever data you want, you store it. Only I want one more data, that is struct, and like say patient, struct patient, and then we'll say next. And this is the pointer.
Okay.
So what will happen now? How this will looks like if you go inside, if you look inside structure, it will be something like this. And you will have whatever information you want, name, age, my address, your address, mother name, father name, medicine, test report, blah, 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 whatever you want, you can have it. But it will have one more, that is called next.
Yes.
And when you do malloc first time, you need to store somewhere this address. So we'll make one variable. That variable will say head. So fine. Now consider this is our first patient come. We did malloc and we store it. Why we are doing malloc?
To reserve memory.
Yeah. So carefully use, say, you will say malloc, I'll do malloc, I'll do malloc. So carefully use your word when you talk in the future.
Okay, sir.
So now listen my word when I say listen my word. Now one more patient come. What I do? Again I'll reserve the memory. How do I reserve? I'll do malloc. I'll do the malloc like this. Malloc will give me memory. And when malloc will give me memory, it will give one address also. In that address, I will write it here in this place. Now malloc work is over. When I later ask, don't say I'll do malloc, I'll do malloc. That malloc work is over. Bimla, I am telling to you.
Okay, sir.
If you have doubt, you can ask. One more patient come, I'll do malloc again. It will give memory. Also, it will give me pointer. And whatever pointer it will give, that address I'll write it here. One more time I'll do malloc. And it will give me memory. And whatever address it will give me, that address I will be writing it here. One more time, one more patient come. One more time I'll do malloc. Whatever address it will give, that address I will be writing it here. And like here I will write the null. Null means my last. Any doubt in this?
No, sir.
No, sir.
Okay. So why I'm not making in one line? Why I'm making here and there this nodes?
Because malloc will only reserve a memory. It won't specify to store in a reserved position.
What do you mean by reserved position?
Like in order.
Yeah. It can store anywhere. We don't know where it is storing.
Yes, sir.
Okay. So
Yes.
keep this thing in your mind. When in future I will ask question, which is answer of that is this one. Okay.
Okay.
Keep this thing in your mind. These nodes are not in a continuous. But in order to understand this better, like I need to make them a continuous memory. So what I'll do is I will make them in a some sequential order, but they are not in sequential order. So I will have one variable. That variable is like it's a head pointer. So it's a head pointer. I can give any name I want. Why I am giving head? A whole world give this variable as head. So I'll also give name as head. And when I first time I'll do malloc, that address I will store it here. And then I got new data, means new patient. So I'm making it here. And that address I'm copying it here. Then one more patient come, so that I'm storing it here. And this address writing it here. Then one more patient come, so that address I'm writing it here. And that address I'm storing it here. And consider, I will say like this is my last, so I will write it null here, just to indicate this is last. But if one more patient come, no worry, I will do here, and then I will store this here, and as well as this null I will move to. Any doubt in this?
No, sir.
So now consider like this 1000 patient come. Can I have 1000 patient entry in this method?
Yes,
Yes,
sir.
sir.
Can I have 2000 entry like this?
Yes, yes, sir.
You can do.
Can we have 5000 entry like this?
Yes, sir.
Yes, sir.
We can have n number of entry. There is no problem with this. Okay, as much as
Yes,
we
sir.
want, we can have. There is no issue in this. As much
Yes,
as
sir.
our memory available, we can keep going.
Yes, sir.
Okay, now consider the patient number maybe 805. Consider he want to go home. He got discharged. So
Okay.
how can I make him discharge? What I have to do? How can I have to update some information for him. So how can I update information for him? How can I get address of 805?
By using head variable, sir.
Yeah, what we'll do using head variable?
Because we are storing every address to the previous pointer, no, sir. So like we are storing our address with the next pointer, no, sir. In the that is storing again here in head only. Maybe through head we can access, it seems, sir. Not sure, but maybe.
Okay, Shekhar, how we can access 805?
Sir, we have to go through 8 only. You have to move 8 pointer to 805.
How to move 805?
Through the structure we are creating the struct next pointer is there now. That pointer we can use and we can move it.
How we can move it?
Like by using 805 in a, anyhow we will store it is an array only, no, sir.
Sorry, array?
We will be storing in array, no, sir.
What array?
In program, like 1000 members means 1000 members, it will be indicated in array only, no?
No.
If we can store in array, then why we are doing all this?
Yes.
Who is holding 805 address?
804.
And who is holding 804 address?
803.
And who is holding 803 address?
802.
And who is holding 802 address?
801.
And who is holding 801?
800.
And who is holding 800?
799.
And who is holding 799?
798.
Who is holding 98?
97.
And who is holding 97?
89. Yeah.
Who is holding 897 number address?
876.
797. 797. Who is
796.
796? Okay. And who is holding 796 address?
795.
And who is holding 795?
Oh, 795.
Then use your mind now. Who is holding 794 address?
793.
And who is holding 793 address?
792. By using 804 we can access 805, sir.
Yeah, but we don't have 804 address. We don't have, no.
So by this again we are coming to a head variable only now, sir.
So what we
Means
have to
Sir.
do with head?
Sir, head variable we copy one variable, one more copy. Where we did keep it in last only. That copy we have to move through using a loop up to 804. That we have to break the child.
How to move? What do you mean by will move? What move?
The address we can we have to print the address we can assign one by one.
What one by one?
Sir, now head address is around for example 100.
Whatever it is.
Whatever it is, for example, I'm telling it is 100.
No, it is head address.
Yeah, it's not head address. It is it store address of first node. The first node now again I will copy one head variable here. Head is keep it the same separately. It will be in same position only. Again that same address I want to move to second node address. Second node address again I copy to 10.
Okay.
Again the third node address I want to move temp one more time. Again I copy the second address in temp. Like that I want to move 804.
Yeah. Like that I will go till 804 and then I will get address of 895. Very good. Okay. And then what I can change whatever I want, I can change it and then I can complete the work.
Yes, sir.
Consider what you said is correct. Perfectly correct. Now consider we reach till 805 and then we realize, oh, we should not come till 805. We have to go only till 801.
Yeah.
What we have to do? How to go to 801?
Return back, sir.
How to return? Consider you reach till here. Consider you reach till here and we have to come back here. How to come?
Again we have to come through it only.
Very good, Shekhar. So, hope you understand this, what I am explaining. Very good. Then now, what is the thing is, in order to save this problem, what we do is we make one more variable here, and that variable is called the previous, like this. So now I will have the two variable. So if you make the now memory map of that, so it will be something like this. So here you will store whatever you want, name, age, address, my name, your name, father name, mother name, whatever you want, you store it here. And this will be previous. This is my first address, so that I will write into one variable, that variable name is head. So this is my first address is stored here. Now previous, who is previous to him?
Head. No.
Who is previous to this? This is my first patient. Who is previous to him?
No one is there.
No one is there. So I will write it null here. And then when my one more patient will come, so I will make it here like this, and then it will be like this. And what I will do is this address I will write it here.
Yes, sir.
And who is previous to him?
First patient.
First patient.
Yeah.
So this address I will write it here.
Okay.
And who is next to him? I will be again doing malloc.
If one more patient is there, that
And
will
one more
be.
patient will come, so then I'll do malloc, and that address I will be writing it here. And then now who is previous to him?
Second.
One. So this address I will be writing it here. And who is next to him?
Next again to malloc.
Next patient will come, and then I'll do malloc. And then this address I will be writing it here. And who is previous to him?
Previous patient.
This address I will write it here. And who is next to him? Consider nobody next to him, so I will write it here. Null. Now consider if I reach till 802, consider if I reach till here, and then I have to go back, so I can use this address and I can go back.
Yes, sir.
And if I have to go back further, I can use this address and I can go back.
Yes, sir.
Understand?
Yes,
Yeah, understood.
Any doubt in this?
No, sir.
sir.
So consider, like say if we have to add, consider if some new patient is coming and user said, hey, in the 10th position you add one more patient. So what we will do is from here we'll go till the 10th position. From here we'll go to next, then go to next, then go to next. Like that we'll go till the 10th position. So consider like we reach here and this is my 10th position, and after that I want to add the one more patient.
Okay.
So what I'll do is first I will do the malloc. Carefully see this thing. I'll do the malloc here. And then now what we have to do is this, for this malloc, who is previous to him? Like I'll write it here like A, B, C and D. So who is previous to him?
Which one, sir?
Who is previous to D?
Is C.
But we are adding it in B now.
We are adding it here. We are adding it here.
So A is previous.
We are adding it here. This place. This place. Who is previous? Where is A in this?
B, sir.
B is previous.
Green. I was seeing green one. I didn't see this. So I told him A. Okay. But now B.
Okay, I am adding it here. This place. You see arrow?
Yes, sir.
Green is the 10th position. Had you heard my earlier sentence?
Yes,
I said
sir.
user said add in a 10th position. So from here I went to next 1, 2, 3. Then I reached till 10th.
Okay,
I said
sir.
like this. This is 10th position. And now I want to add. So consider I want to add this. So after 10th I want to add it here.
Okay.
So who is previous to him?
B.
B. So B address. This is the address of B. So this address I will write to the previous this place. And who is next to him? Who is next to D? C. C address how can I get? Who is holding C address?
B is holding. Already B is holding this C address.
B is holding?
C address.
C address.
Where?
There it is holding. Sir.
What is this?
Next pointer.
Then say that na. B is not holding. B next is holding.
Yes, sir. B next is holding.
So from B next, we'll write it here. Any doubt till here?
No, sir.
Now, the B next, currently it is C. But once this will come inside, who will be next to B?
D.
D, sir.
So the D address I have to write it here.
Yes, sir.
Once I write D address, then this connection is gone. This connection is gone.
Yes, sir.
Okay.
And then from D, D next, this one.
Yes, sir.
Which address it is? D next?
C address.
C address. So that C previous means this one.
Yes.
Who will be previous to him?
D.
D.
D. So that D address I have to write it here.
Yes, sir.
Understand?
Yes, sir.
Understand.
Now you see who is next to A? B is next to A. And who is next to B? That is D. And who is
D.
next to D? That is C.
C.
And who is previous to C? That is D. And who is
B.
previous to D? That is B.
B.
And who is previous to B? That is A.
That is D.
So that's how we can add node in between also, like that.
Okay. Sir.
Understand this?
Yes,
Understand.
sir.
Now consider same way user said, no, I want to delete some node. Consider user said, I want to delete the 20, listen carefully Bimla what I am saying. Consider
Okay.
user said delete the 20th node. So
Okay, sir.
from head I will be moving next and I'll reaching till 20. And consider I want to delete this node. So you'll see, listen what I am saying, where I am marking.
Okay, sir.
Don't say I see an arrow. I consider I reach here and this node I want to delete it.
Yes, sir.
Okay, so now what I will do, listen carefully. This address means A address, previous address, this one. Previous address, next address, this one. So A address next. So this address I will be writing it here.
Yes, sir.
I'll say again, A address, previous address, next location, I will be writing this address. I already have that, so that I am writing it here.
Yes, sir.
Same way now, A address, next address, previous address, this place. This place I will be writing it, this address,
Yes, sir.
like this. So what will happen now? Once I write, once I give this connection, then this connection
This
gone.
one, sir.
Now this is connected, as well as this also no use, because I got new address now here. Same way, this blue connection is established, so this connection is gone.
Okay.
And since I wrote here new address, so this also does not have any meaning. Now you can see like this node A is gone. Now it is no use. This is gone.
Yes, sir.
Because who is next to first address? This one.
D. Yes, sir.
And who is next to him? That is already
This
there.
also D.
And who
D.
is previous to B? So this directly this
This
address.
also D.
So we can easily delete this.
Yes, sir.
So this is how you can remove node, add node, remove node, like that.
Okay. Sir.
Did you understand what I say?
Yes, sir.
Yes.
Do one thing, do the practice of this thing, and
Okay.
it will be, do as much time. Don't think like it is very simple kind of thing. Whatever I am explaining, if you
Okay.
understand very well, it will save your at least 2 week, 3 week time it will save.
Okay, sir.
Oh,
Okay, so you understand well to make diagram this as much as time possible. Which
Okay, sir.
address need to go where, you should have very clear understanding.
Sure.
okay.
Sir.
Do that one. Spend at least one day on this, at least 2-3 hour, 4 hour on this, and try to grasp it very clearly.
Sure, sir.
Okay, yeah, that's all from my side for today. Do that one, then we'll see.
Okay, sir.
Thank you.
Okay.